All right, so if you are able to see the book, it's fine. I am going to start recording now. We ended on resistivity last time, you remember?
That's correct.
Yeah, we did resistivity. And then today I'm going to start on resistance. Okay, we have two types or two ways in which we can connect a resistor. The first one is in series, and then the other one you can connect a resistor in parallel. Okay, so you need to know what they are asking, if it's a series connection or it's a parallel connection. And then if it's a series connection, how do we do the calculations? Like the first part here. And the first thing you need to know is what is the purpose of a resistor on any electric circuit diagram. These resistors are put in electronics or electrical circuit diagrams for regulating the current flow, to regulate, to either allow current to flow or not to allow current to flow. So if you need more current to flow in the system, you need to have a low resistance resistor. Because we talked about a resistance, what it does. It restricts the flow of electrons. So if it has got higher resistance, like you've got 24 ohms and the 12 ohms here. The 12 ohm is just not resisting too much, but 24 is resisting too much. Okay? That is what we mean by, resistance. So we talked about Ohm's law last time that says that the current flow in the circuit is direct proportion to applied voltage across the circuit. This formula I gave you last time. It's V or I equals to V over R. So they just write it in this way. Otherwise, it's I equals to V over R. And current and voltage are directly proportional as long as the temperature remains constant and as long as the pressure also remains constant. Then current and resistance, they become what? Inversely proportional. Do you remember that?
Yeah.
Meaning that when you increase current, what happens to resistance? Low.
Yes, yeah.
Yes, that is inversely proportional. When we say current and resistance are indirectly or inversely proportional, it means that when you increase one, the other one reduces. So when you increase resistance, current and current will reduce. The higher the resistance, the lower the current. Yeah, the lesser the resistance, yes, the more the current.
Just quick question. The screen is black. It's not showing anything anymore.
Oh.
I've got the book open here by me, but yeah, the screen went dark for some reason.
Okay, let me just try to check what is happening there.
It's back now.
Is it back now?
Yeah, as soon as I said it, it came back.
And then you are able to see?
Yeah, I can see it now again.
Okay, I'm sorry, I don't know what happened.
No problem.
Okay, so what I'm saying is the resistance in series is going to work with Ohm's law. Even when I come to resistance in parallel, Ohm's law is going to be applied. But the relationship you have to know among these three things, current and voltage, they are direct proportion. When you reduce the other one reduces. When you increase this one, the other one increases. But current and resistance, they are inversely proportion. Then voltage and resistance, they are directly proportion. When the resistance is high, the voltage reduces or increases also. Voltage drop, we call it a voltage drop. There are also directly proportion. R and V, they are direct proportion. The higher the resistance, the higher the voltage drop. And then current and resistance, they are not directly proportion. So now let's look at this. When we talk about this electronic circuit diagram, you have the cells here, which is the supply voltage. They are saying that 400 volts is coming from the battery. So this is a battery with two cells. How do you count a cell? It's a positive wire and a negative wire is 1. Positive and negative 2. So you have two cells here, but the total of the voltage from the two cells is 400 volts. That is the potential or EMF we talked about last week, not potential drop. EMF, electromotive force. It's the total voltage coming from the supply. So according to conventional current flow, current will always flow from positive side, which is the long side, going that way. That is how current is going to flow this way. So when we come to series setup, series means you have a wire, and along the same wire you have a resistor, another, in the same line. Even if it's making a corner here, they are in the same line. They are not in parallel. So when we connect resistors in series, the important equations are these ones on your right hand side. The first part is EMF. What is EMF? Electromotive force. It is the voltage. Like this 400 volts, for them to get 400 volts, they had to deal with different cells added together to give them 400 volts. So they're saying EMF is equals to cell 1, voltage of cell 1, plus voltage of cell 2, plus voltage of cell 3, and so forth. You can have as many cells connected together to give you the total EMF, like 400 volts. Then in series again, when we come to voltage drops, you see they're saying VT, total voltage drop. V1 plus V2 plus V3. What are these voltage drops? When I talk of V1, it's the voltage that one resistor is dropping. When you take your voltmeter and hold it across the terminals from here to here, you want to know how much voltage is this resistor dropping or losing from the 400 volts. That's what I was teaching the other time. To say when I check the voltage across this resistor, if I get 50 volts across here, or it's losing 50 volts, the EMF is not going to be 400 anymore. The EMF is like 400 minus 50 volts. On your voltmeter, you're not going to see 50 volts. You're going to see 350. Because the total was 400, then this one drops 50, assuming we don't have this one here. There's only this one and the supply. So whatever the voltage that will be dropped in this resistor must be taken out from the supply. We are talking about the potential difference, which I told you last week that potential difference is the EMF minus the voltage loss in a resistor. A voltage drop is called a voltage loss. So when you see V1, V2, V3, these are voltage drops or voltage losses across resistors. So V2 will be the voltage dropped by resistor 2. V3 is voltage dropped by resistor 3. But the sum of all the three voltages in the circuit must give you the total supply voltage, which is the EMF. Okay, so if I want voltage dropped by this resistor here, okay, I must take my voltmeter and measure across from here to here. The answer I'll get here is this voltage supply minus what this is dropping minus what this is dropping. That is the answer I'm going to get across here, because it's a potential difference. A potential difference is when you take the total voltage minus the losses, then you get a potential difference. But the sum of these losses, let's say voltage loss here and here, and then there's another resistor here that is losing another voltage, which is V3. When I add V3, voltage loss by this resistor, voltage loss by this resistor, and voltage loss by that resistor, all the three voltages must give us 400 volts. And that is what they call VI, total voltage, VT, total supply voltage, or EMF. It is called EMF. Is the sum of all the voltage drops or voltage losses. Any questions?
No, I'm following so far.
Okay. The other equation, this equation is not applicable when I come to parallel. This is only for series. And series, you must always think of a line, even a pipe of water, that you're going to connect a flange, a coupling, in the same line without any branch. Immediately I extend this wire out here, I'm creating a parallel because I'm creating a branch. Here there's no branch. The line is the same, even if you are bending, it's the same line, same current flow. In series, the current is the same. This is this equation, that is the second equation. What are they telling us about this equation? They are saying total current, which is the current from the battery here, total current is equals to current 1 is the same current here, again is equals to current 2. And if there's another resistor, which is the third resistor, that will be the same current in third resistor. Even I have 20 resistors in series, or even there are 100, current will be the same. It does not change. That's the series connection. Clear?
Yes.
Okay. The third equation is talking about resistance. What happens in series? How do you get total resistance when you have a series connection? Total resistance in series is just adding resistor of this one plus the resistance of this one plus the resistance of this one plus, even if you have 20 resistors, you have to add them together to give you the total resistance. That is series. It's just 1 plus 1 plus 1. Add everything together. That is a series. So these three equations, 1, 2, 3, do you know that they are coming from Ohm's law? Voltage, if you want total voltage, you add up all the voltage losses or drops across resistors. If you want current, it's the same current at any point in the wire. Even they tell me that the battery is supplying 2 amps. What is the current in resistor? 24 ohms. It's the same 2 amps because they are in series. Okay.
Yes.
Okay. And then electrical, you must remember they don't give you the formula sheet. So these equations, you need to know them by heart. There's no formula sheet in this paper. But I told you already, the goodness with this subject is that it's only less than 20% of calculations and theory.
Yes,
Theory
yes,
plus
yeah.
calculations is only 20%. 80% is drawings, so
Yes.
no stress. Okay, let's check this question. It's an example here. They are giving you 2 resistors, each with a value of 12 ohms and 24 ohms, are connected in series across a 400 volts supply. Already you know EMF is 400. One resistor is 12 ohms, the other one is 24 ohms, which is this setup here in series. Then the question says, what is the total resistance? It's just R1 plus R2 because they are in series. Then, what is the current flow in the circuit? You need now to know the current flow. But which equation are you going to use to get the current flow? Ohm's law. This Ohm's law is used anywhere at any time in the circuit, whether it's series, whether it is parallel. You use Ohm's law at any point, whether for the total things or for the resistor 1 or for resistor 2, work with Ohm's law. What only changes is the values. Maybe resistor 1 can change, maybe this voltage can change. Like in this case, they're asking for the current flow in the circuit, which is total current. When you hear of current flow in the circuit, it's the total current. And that's why here it's IT with a small t here, total current, equals to VT, which is total voltage, divided by RT, total resistance, which you already got 36 as a total resistance. VT is given. Can you see supply voltage is 400 volts?
Yes.
Then divide the 2 and get current in amps. 11,11 amps. Current is measured in amps. Ohms is resistance. Okay. Then the last question, they are asking you to calculate the voltage drop, which is the voltage loss across each resistor. This equation of voltage drop, you will never find it in parallel. You will see when I show you a parallel connection. So they want how much voltage will be lost by this resistor and how much is the voltage across this resistor. You are also going to use Ohm's law. Like I said, Ohm's law can be used for the entire circuit and can also be used only for one resistor. So if I want the voltage only in this resistor, I'll say I equals to V over R. But which R is 12? Which I? Total current, because its series current is the same. You already solved current here. You see this current here.
Yeah.
It's the total current from the battery. But this same current is the same current you will find across each resistor. There is the equation that says current is the same. Right?
Yeah.
Okay. So let's check how they solve the voltage drop. Check the formula. V1. Why V1? Because it's voltage across resistor 1. equals to current T, total current is the same, times R1. You manipulate your equation from that one. Let me show you. From this one, I equals to V over R. So if you are looking for V, you multiply these two. R times I equals to V. That's what they have done here. V1, not VT. VT was the total voltage. You are looking for the voltage loss across resistor 1. So it's V1 equals T. I total, because current is the same. There's no I1, I2, I3. It's the same as I total. Then times R1, resistor 1, 12. This is the voltage that is lost by resistor 1. 133.32 volts. How much will be lost by 12 ohms? This is 12 ohms. 24 ohms, check the voltage drop. I already told you that voltage drop is directly proportional to resistance. So if you see the resistance is high, just know that it will lose too much voltage. Check here, even this can tell you. This is 12 ohms, only losing 133 volts. This is 24, almost 2 times. Can you see?
Yes.
It's also talking about Ohm's law, that voltage and resistance are directly proportional to each other. Then voltage and current directly proportional to each other, but current and resistance inversely proportional. But here in series, you can't say current will increase as more resistance has reduced. No, current stays the same in series. Where we say current and resistance at the indirect proportion or directly proportion is when we come to, which one is that? Parallel series.
Parallel.
Yes, they are indirectly proportional, I mean. So you see the example, this is the example of a parallel connection. There you have a supply of 380 volts coming from this battery. Check the arrow. The arrow shows the current flow. This is the direction in which current is flowing. Current is flowing like that. When it reaches this junction here, can you see how current is going to split? One will come in this line, the other current will go to the other line. So we call that current 1, current 2. Current is splitting. That is in parallel. And what they say is the current coming into this junction here, which is I total, IT, must equals to current leaving the junction. Which is the current leaving the junction? It's I2 and I1. Which is the current coming into the junction? It's I total.
Yeah.
So the formula is I total equals to I1 plus I2. This is the formula here in parallel. I total equals to I1 plus I2 plus I3. If there was a third one here, you add all the three together. That is total current. So in parallel, current is not the same. You have to be able to calculate this I1 and this I2. Examiner might ask you, what is the current in resistor? 150 ohms here in this resistor. Then you use Ohm's law in this specific resistor. You are going to say I1 equals to V over R1. In parallel, voltage is the same. Check this equation for voltage. VT, total supply voltage. Voltage across here is 380 volts. Then what is the voltage across this resistor? It's also 380 because voltage is across. What is the voltage here? It's also 380. That's why they are saying VT equals to V1 equals to V2 equals to V3. The voltage is same in parallel. It's constant in parallel. Clear?
Yes.
Okay, let me take you a little bit backwards. Let's see. I want you to see that when you talk of V1 plus V2, it should add up to voltage 400. We said, there is the formula. Total voltage is V1 plus V2 plus this V3. But yes, in our case, we only have V1 across resistor 1 and V2 across resistor 2. But when we add them, are we getting 400? Yes, we have to get 400. Check. I got 266.64 voltage loss
I
by...
saw that. a 0 point something loss. It's not 100% 400 there, but yeah.
What is 133.32 plus 266.64?
399.96.
Yeah, it is. When you round off, it's 400.
400, yeah.
Yes. It's 400, correct. So that is what you must always aim to get when you're in doing series connection, that the voltage drops, when I add them together, I must get the total voltage. But when we come to the parallel connection, I must make sure that the currents are balancing according to that formula. You see, in parallel, current should balance. Total current coming from the battery must be equals to current 1 plus current 2 plus current 3 if there is a third current. There is another branch. You can have as many branches as you can. Okay, that is what we mean. So this formula you can also use. They are saying only if you have two resistors in parallel and you want total resistance, because the third equation is this one. In parallel, to get the total resistance, you must say 1 over RT, R total, equals to 1 over R1 plus 1 over R2 plus 1 over R3, if they are 3. If they are 5, continue adding until you get that. But this equation that you see down here, this one here, it's only meant for 2, when you have 1, 2 in parallel. Then you want the total resistance of those 2. Just use this R1 times R2 over R1 plus R2. It's very easy. But I'm saying only if there are two resistors in parallel. If there are more than 2 in parallel, you have to go with that formula. So meaning that you need to know your mathematics. How do I change the formula to RT? What you do, you are going to put the numbers here. 1 over 5, 1 over 6, 1 over 10. Then calculate or punch on your calculator. Whatever answer you get on the right hand side must go and divide into this one here, and that is your RT. Did you get my point?
Yes.
You are manipulating the formula. So I'm saying whatever answer you get on your right hand side, well, you add the 3 fractions. If the answer is 0,002, take that 0,002 and divide into 1, and that is your final RT.
Okay.
Because I see students just leaving RT as 0,002. They are forgetting to cross multiply. You have to do cross multiplication to get RT, the subject of the formula. All right.
Yep.
Okay, let's discuss this example. 2 resistors, each with a value of 150 ohms and 450 ohms, are connected in parallel. So you are supposed to draw a sketch. Okay, so you have 2 resistors connected in parallel across 380 volts supply. Calculate the total resistance. This is a supply. How do you get total resistance? Because there are only 2, you can use that formula if you want. Or you just work with this normal formula. 1 over RT equals to 1 over R1 plus 1 over R2. What is R1? 150 ohms. R2 is 450 ohms. They got the answer here. This is the fractions. Whatever answer you get here, remember to divide into 1. And that is your RT. So I don't know if you have a calculator there. I wanted you to use the other method. 1 over 50 plus 1 over 450. Then,
I don't know. I have one with me now.
Okay, it's fine. Next time you need to have. Then the answer when you get here, just go and divide into 1 here. Then that is the final answer. Because here what they are showing you is the steps on how to do fractions. You know, like it's mathematics. They take the common denominator. 450 is a common denominator. 150 into 450, 3. 3 times 1, 3. 450 into 450, 1. 1 times 1, 1. Then 3 plus 1. Then they get that, you know. It's fine. The easiest way is what I'm saying. Just add up everything on your right and then divide into 1. Clear? Any questions?
No.
Okay, let's move on. Okay, the next question was asking about what? Let's check. Current flow through each resistor. Why? Because it's a parallel connection. So now they want what is I1, what is I2. It's branching off into resistor 1, resistor 2. How do we get the current flow in resistor 1? Then you come and work with what? The formula, which is Ohm's law. I1, meaning you want current 1 into resistor 1. I1 equals to VT. Why VT? Because total voltage is the same across any point in the parallel resistance. So they are using the same voltage as supply here, 380. R1 was 150. So just take the EMF divided by resistor, the resistance of a resistor, and there is the current. When you come to current number 2, you take total voltage, because the voltage is the same in parallel, divided by 450, there is the answer. So this plus that is the total current, in case they asked you to get total current. But this is a long way you can get total current. Just in case the question was there asking for total current, the only way you can get total current is by coming to Ohm's law. You know, like that equation. I'm going back again. This formula. Can you see? You can use that formula. IT equals to 380, which was total voltage, total resistance over total resistance. Then you can also, the same equation here must give you the same answer that you get when you do the current separate. Here you do current 1, current 2. When you add them together, must give you the same current you get when you say IT equals to VT over RT, as long you use total resistance on RT, and VT as long you use total voltage, which is 380. The answer will be the same, but I'm saying this is just a long cut. Other than that, you want to balance or to prove that the answer is right. So you need to come this way and then add the 2 compared to that formula you used, which is Ohm's law, and see what is the current total that you're going to get. It must be the same. If it's not the same, it means you might be wrong somewhere. Any questions?
Not now.
Okay, let's move on. And number C, let's see what are they asking here on C. Total current flow. Okay, there it comes now. So now they're asking for total current flow, of which you can add these two together, or you can use Ohm's law. So they are using Ohm's law here. You see, IT equals to VT over RT. Total voltage over total resistance. There is the current. Or you can add I1 plus I2. Check the answers.
So if they ask for total current flow, do I need to use Ohm's law, or can I use just the example on the right?
Anyone.
So any one of them is going to give me the
Correct.
same point.
It will give you the
marks.
correct answer, yes.
But for marks, I'll get just be marked on the how marks, I got to the answer.
Yeah, for marks, just one option is fine.
Okay.
Okay. Only one. They're just saying you could also get it in this way or that way. Just one. Don't show both methods. Cool. All right. So when we talk of resistors, like when we come to households, in the house, a resistor can be any appliance in your house. Let's say you have a wiring system from your distribution board into your house, maybe into your room where there's a TV. But that wire, maybe before the TV, it's supplying something else, the same line is supplying electricity somewhere. That is what we call, connection of resistors. Even a computer, when you come to the classroom, we have a computer 1, 2, 3, 4, 5 in one row. Those computers are not in series. Usually we connect them in parallel. Why we connect appliances in parallel is to have the same amount of voltage across the terminals. We mostly in the house, all appliances are in parallel. When I talk of lighting in any room, if you have 10 lights in your room, just know they must be in parallel. Why? We want the same voltage across the lights, even if the current is different, but the voltage should be the same. Okay? So, because we are now talking about household appliances, you need to know how to calculate the power of an appliance. Maybe it's a TV. You know the resistance of a TV, how to get it. I've given you all the formulas. I've given you the formulas to get the voltage of the TV or any appliance. Now, you need to know how to calculate power consumption. because power is consumed by an appliance. How much power is the TV taking from the total supply? How much power is the stove taking from the supply? We need to know the formula for power calculation. Not only power calculation, we also need to know the energy calculation, because there's energy consumed in a certain period of time. Energy is the amount of work done by electrons as they are moving around. You know how much energy is consumed in the circuit. And there is a relationship between energy and power. And there is a relationship between power and current and voltage and resistance. And you can see the formula first of power. Power is the rate of work done, or the rate of doing work, or the work at which energy is done. You know, there is the formula. Power is voltage times current. So should they ask you for total power in your house, you are going to get the total voltage supply from the distribution board times the total current from the distribution board. Then you know how much power is going to your appliances. But if I only want power consumed by the stove in the house, I have to have knowledge of the voltage and the current into the stove. Then I will multiply voltage across the stove and times current of the going to the stove. Okay.
Yes.
So other than this formula, if you have current and resistance available, you can also get power using current and resistance, but the power is going to be the same. The power you get here is going to be the same power you get in the second equation, as long you use correct figures for current and for resistance. So if I want power of a resistor, not for the entire circuit, I need to know what is the resistance of that resistor. What is the current that is going to that resistor? Then I multiply the two. Then I get total, or the power for the resistor only. And when they say total power in the circuit, they want the entire power. You consider total voltage, total current in that case. If the question is asking for total power, is VT times IT. So you must know the difference in the questions when they say, what is the power consumed by resistor 1? Oh, resistor 1, I need voltage across the resistor 1. I need current in resistor 1. And then sometimes the question can come, what is the power consumed in the circuit? It's the entire power, total power. In that case, you must take into consideration the total voltage and the total current, or total resistance versus total current squared. This is I squared. All V squared, which is total voltage squared, divided by R, which is total resistance squared. The answer you get here and here and here are the same. Just use one formula. It depends with what information you have available. Easy.
Yeah.
Okay. The unit for power is watts. I think we know that power is measured in watts, capital W. So if your power is 20, don't just write 20. You must say 20 watts with a W. Then when we come to energy, energy is the work done in a certain time. The amount of work done in a period of time is called energy. Another formula for energy is power times time. Okay, there's the formula. So if I asked you for power consumed in your house, you can also get it by saying energy over time, because power is energy or work done in a unit time. I don't know if they gave you that formula for power. No, they didn't give you, but you can get it here. If I say make power the subject of the formula, it's going to be power equals to E over T, meaning power is energy over time. If we need energy, we just say power times time. It's just manipulation. And then energy is power times time, but power again is voltage times what? Current. So make sure that your time is in hours if you are working with energy, especially in a unity form. But normal energy in joules, you know energy is measured in joules. Make sure that the time is in seconds. If you want the energy in joules, the time must be in seconds. Okay.
Yeah.
Okay, there's the formula you can also use. Energy is V squared over R. Why V squared? This is power. V squared over R is power. So power times time is still energy, but the energy in joules. That's the unit of energy. So there are times in the exam, the examiner is giving a situation like in a certain household, the geyser was switched on maybe at 01 in the morning and only switched off at 5 o'clock in the morning. And then they find that the power consumed by the geyser is 2 kilowatts. Okay, what is the energy? You are going to know power is given. Time is 2 hours. What will be the energy? If you want the energy in joules, change the power into watts, because 2 kilowatts is 2000 watts. Put 2000 watts here, times time in seconds. How many seconds are in 2 hours? If it was switched on for 2 hours, let's say, or 5 hours, whichever. If it's 0, 1, 2, 3, 4, 5, 4 hours, the geyser was on. So that is what municipality is doing. Before they give you a bill, they have to know how long you leave your things, your appliances on, and what are the power consumptions for all those appliances in your house. And then what they get on your meter reading is kilowatt hours. You know that, eh?
Yes.
Kilowatt hours. Why they say kilowatt hours? Because they measure in a unit as a kilowatt hour, meaning power times time in hours. Kilowatt power times time in hours. They say a kilowatt hour. But if you want your energy to be in joules, you can change the kilowatt into watts and the time into seconds. Then our answer is still the energy, but in joules, not in kilowatt hours. Sometimes they have asked before, like 5 days, you know, this appliance was left on for 5 days. What will be the energy consumed in that 5 days? So you have to change your 5 days into seconds, which is 5 times 24 hours times 3600 seconds, because we know that in 1 hour we have 3600 seconds. Am I right?
Yes.
Yes. So if I give you 5 days, you need to change 5 days into seconds. It's 5 days times 3600 times 24 hours, because each day there's 24 hours. Okay.
That's going to be a long calculation.
It's been, yes, usually they ask like that. And then your power must be in watts if we want our answer to be in joules. But if they say what is the energy in kilowatt hours, then leave your power in kilowatts and the time in hours. Any questions?
No, I'm good.
Okay, let's check this exercise here. This exercise they have given, there are about 3 questions. I'm going to guide you, but have time to go through and then send me your calculations, okay? You need to have time to go through. It's page 10 of the second book that I've posted there. A circuit consists of 3 resistors connected in series with values of 50 ohms, 100 ohms, and 150. So there are 3. All of the 3 are in series. If the voltage drop, meaning voltage loss, across the 100 ohms, on this 100 ohms, is 110 volts, V drop, it's losing 110 volts, this one. Calculate the following. Total resistance. How do you get total resistance?
It will be adding up the no, it's not adding up.
Yes, easy.
Adding up the resistors, isn't it?
It's easy, series, 50 plus 100 plus 150, 300 ohms.
Yes.
Next, what is the total current flow? Which formula are you going to use to get the total current flow?
Total current's also the plus together the resist. No, it's not. Wait. Total current.
That's why you need to be drawing sketches when you get a question like this. You create a sketch.
Yeah, because I'm working it in my head now and I'm confusing myself.
No, we don't have total current. We don't have total voltage here. I think you can see they didn't give us total voltage. So why did they give you 110 volts? They said that the voltage lost by 100 ohms is 110. So these two, do you know that you can work with 110 and 100 to get current in that resistor? Because you have ohms, 100 ohms and 110 volts. You have V drop across one resistor at least. You are going to work with Ohm's law for resistor 1. There are 3 resistors, one here, one here, one here. But this second resistor, when they measure across, they are getting 110 volts that it's losing. So for you to know what will be the current going into that resistor, is it not going to be voltage over R, V over R? That is I equals to V over R. You are using this formula. Where is Ohm's law? Back to Ohm's law, not this one. This one. What are we looking for? We are looking for current. So voltage 1 is given. It's 110 across that other specific resistor. And its resistance is 100 ohms. So it's just the V drop across that resistor, which is V1. It's like you have a circuit like that, not this. This is parallel. Yeah, but you are going to work with that resistor, 100, and the voltage it's losing, you put on top. When you divide the two, you are going to get the current in that resistor. But because it's series resistance, you are going to know that the current is the same at any point. The same current for R2 is the total current, is the current at R1, is the current at R3. So we work with resistor 2 to give us how much current it's taking. But in series, current is constant. So whatever answer you get is the same everywhere.
That's in series?
Yes. That's in series.
Okay.
This question is a series question. You heard they're saying there are 3 in series there. Series with values 50, 100 and 150. But this one has a voltage drop here. So already this is got enough information. Only one is missing. I can't use 50 because I don't have current in 50. I don't have voltage in 50. I can't use 150. There is no current. There is no voltage in 150. I can't also use total voltage because there is no total voltage given here. If they gave a total voltage, I was going to just work with total voltage, total resistance. Then I get total current.
Okay.
So in this case, even when you find a question like that in the exam, they are just playing with your mind, just tricking you. We see if this person knows that current in series is the same. Because in series, IT equals to I1 equals to I2. So we have solved I2, which is also I tot. Clear?
Yes, yeah.
Okay. Then you're going to get the voltage drop across the other resistors. They want now what is the voltage here that will be lost by this resistor. And what is the voltage that will be lost here. You are also going to work with Ohm's law for 50. We are going to say I, or just V equals to I times R for this one. I is given. Whatever answer you got here for total current is also the current in here. So work with that current that you solved here, okay, multiply with this one, then you get the voltage in here. Whatever current you got in that B times that one, you get your voltage here. What are we doing? We are calculating this formula, not power, current and voltage. Here, if I need current, I divide voltage times, or divide by R. But if I need voltage, I times these two, I times R, to get voltage. So like in resistor 50, they want the voltage. So you are going to say total current times resistor of 50. Then in resistor of 150 again, it's going to be 150 here times the current that you have solved as a total current, being that current is constant. Okay.
Uh-huh.
Yeah. Then lastly, they want the power of the circuit. What is the power? When they say power of the circuit, they want the total power in the system. What do you do to get power? V times I. So total voltage times total current.
Current.
Yes. That is for total power. You use with total everything. Total. Okay. I need you to solve this in your own time. I'm just guiding you. Then E, energy used in 10 minutes. We said that energy is power times time. So the power you get in D times this time, but make sure this time is in seconds. How do you change minutes to seconds?
Minutes to seconds you divided by 60, isn't it?
Times.
Times, yeah, sorry. The other way around.
Times 60. So it's going to be 10 minutes times 60 times the power that you solved there in watts. Then that will be your energy. But the power here, obviously, it's voltage times current, or any other formulas you can use that here. You can see I gave you all those formulas. Yeah. That is how you get number 1. Question 2 is a bit tricky, but let me see how you're going to try it. Then when I meet you next week, if there's any challenges, I might start first by going through these questions before I carry on. So they give you two resistors of 12.5 ohms and 35 ohms and are connected in parallel. So these two are in parallel. Then the question is, calculate the value of the third resistor that will be connected in parallel with this combination. So you have two parallels, can you see? Plus the third one, 3. But the value of the third one is not given. That's what it says here. Two resistors of 12.5 ohms and 35 ohms are connected in parallel. Fine. Calculate the value of the third resistor connected in parallel with this combination to give a total resistance of this. So they are saying when you take these 3 and put it in parallel, the total resistance of the 3 is 8. Okay? Is 8. So there are 1, 2, 3. The third one we don't know the value, but the total we know. If I take you back to the formula here, where's that? Here. This is the equation, but here they are giving you 3. 1, 2, 3. So it's 1 over R1 plus 1 over R2 plus 1 over R3. But the third one, R3, we don't know. R2 they have given you. R1 they have given you. R total is 8. You replace this one with 8. You replace this one with a value of 12. I don't know, 12.5 and 35 here. The only unknown is R3. So you need to manipulate your equation to solve for R3. You have to play with your mathematics and solve for R3 because everything is given. Clear?
Yes.
Yeah, that's the first part. Then the same formula, okay, the same question, they're asking you to calculate the total current flow. It's a parallel connection. So if you need total current flow, the only way you can do it is knowing the total voltage. Where is that? Total current flow. Okay, here first, A. Current through each resistor. So when we come to parallel connection and you want current through each resistor, you must independently work with resistor by working with I equals to V over R. I1 equals to V over R. Voltage is the same, which is 200. It won't change. That is the supply voltage. Because it's a parallel connection, voltage is constant. So when I want the current in resistor 1, I'll say I1 equals to V1 over R1. What is V? 200. What is IR1? 12.5. Then I get current in that resistor. I go to the second resistor. I2, meaning current in that resistor, equals to V, same voltage, over 35. Then I go to the third resistor. I3 equals to V total, which is 200 volts, over the answer you get for the third resistor, because that was the first question here. The answer you get for the third resistor, you divide it into 200. That will be the current in the third resistor. And that is done. Once that is done, here they want current, total current. You add all the three currents. That's why the first question is current as in independent currents in those resistors. Then after that, they ask for total current. Add up I1 plus I2 plus I3. Then your answer is total current. Or else, you can say I total equals to VT, V total, over R total. Because R total, you can come and get total current of resistance is 8. So I total can be equals to V total, which is 200, over RT, which is 8. So 200 over 8, you are getting your total current. That is using Ohm's law. Apart from using Ohm's law, you add all your three currents that you are going to solve in A here. Any question?
No.
Okay, so the last one is power in the circuit. When they say power in 35 ohms resistor, they are specifically wanting power in here, power consumed by this resistor. Use those formulas for power, but make sure that if you use I squared times R, you use I going into 35, which is second current, times 35. Whatever you are looking for must be relating to 35. So we need power in this 35 ohms. Make sure the current is the one for 35 ohms, though the voltage is the same. And the resistance should be 35, not any other resistance. Then from those power equations, you take one that you can use to solve the power here. Okay, the last one is energy in the circuit. When you hear energy, it's the total energy in the circuit. How do we get total energy? For 2 days, which I've already mentioned, you must change 2 days in 2 seconds. And then energy is power times time. Then what is total power times total time? Total power is voltage total, which is VT times I total. I total you already solved here. So total current times total voltage of 200 times the time in seconds, 2 times 24 hours times 3,600. Then that's your energy in joules. Easy.
It sounds easy, but to remember for the exam.
I know. But I hope they will ask you. You know, some question papers just come without not even a question on calculations.
Because I know my mathematics is going to drop me, but I'm gonna give it a go and try.
Don't worry. Like I've told you, we might just find the paper. There's no even calculations, but you just need this for the sake of the industry. You know, you're dealing with people with calculations and stuff. You need to know at least some basic calculations.
Yes.
So that's how you do question 2. Then question 2 and 3 is almost the same, but question 3 is showing us that it's a combination of a series and a parallel. And I know next week when I meet you for this subject, I will need to show you how to do question 2 and 3, especially 3, because it's not series, it's not parallel, but it's combined.
They're combined into one.
Yeah, you see 2 resistors of 6 ohms and 18 ohms are connected in parallel. So only these 2 are in parallel. Then this combination is then connected in series with a third resistor of 7. So this 7 ohms is connected in series to these 2 that are in parallel. So it's a parallel versus a series in one.
Okay.
But, so it's not that challenging. You need to make sure you break down your parallel into a series. Once you break down 6 and 18 ohms into one ohm, or not 1 ohm, one value of resistance, then that value you get here must be in series with 7. And then how do we get this one here? It's 6 times 18 over 6 plus 18. Remember that one for 2 resistors in parallel.
In parallel,
Yeah, because there are 2. Once you break it down into one single resistor, that single resistor will now be in series here. Then we can apply series throughout. Yeah.
Okay.
And then they are saying that the 7 ohms resistor has got a current of 10 amps. Already, if you know electrical, you know that this 10 amps is total current because it's the current going through 7 ohms. So it should be the current from the supply. That is the total current because in series current is the same. So this 10 amps is the same current that are going to flow through 6 and 18 together. I'm not sure how much current 6 will take and how much 18 will take, but the sum of the two currents needs to be 10. That is what we learned. Current is branching off. The current coming in must be the sum of the two currents leaving. So if you look through this, they were looking for total resistance, supply voltage. What? Go through this the same way we have just gone through, making sure you change hours to seconds. If you are looking for energy, power is energy over time. Go through total resistance. Obviously, total resistance, you get this total plus that total. But this, you can't add 1 plus 1. No, it's a parallel. Okay. Only the answer you get for these two when you do parallel calculation then can be added to 7. Then it gives you total resistance. Supply voltage. You already have total current of 10 amps and the resistance you have gotten here. So total resistance you have, total current you have. You can get total voltage, which is your supply voltage, using Ohm's law. Then current through the parallel resistors, you calculate current through each resistor now. I1 equals to V over R1. I2 equals to V over, you must do that. Okay, I'll end here. Let me see what you can do. And I'm going to post the recording. I want to see if others can also try and see your answers. And then the next time when we meet, I'll start by going through these calculations and then we close the chapter. Then I'll carry on through to temperature coefficient, and it's going to be theory. I'm sure I'll finish the theory on that day. Immediately I explain next week, it means the week after is drawings now.
The nice part of it.
I know.
The two questions we need to do now, or try, for the exercise. Must we send it on email to you?
You can send on my WhatsApp. Just take a picture of whatever you have done. For all the three, there are 3 questions.
Yeah, the exercise on page 10 and top of 11.
Yes, page 10 and 11. So do that one and then let me see how you are getting it. I'll correct you there.
Okay.
Okay.
That's the only way I'm going to remember this is by doing a few examples.
I know mathematics is such a challenge. You need you guys to come and do Maths N2 here. I'm teaching Maths on Saturday. Basic mathematics.
I think I'm going to have to because,
you need to register.
My brain, but I think it's literally just because I need to do a few, because my brain, once I see myself doing it, I'll remember it.
All right, no problem. Let's see. We'll meet maybe tomorrow for SSD.
SSD is Thursday.
Oh, it's Thursday. Tomorrow I'm not meeting you. Okay, no problem then.
Okay, thank you so much.
Okay, it's my pleasure. Keep well.
You too, thanks.
Bye.